Hello everyone and welcome to MATLAB tutorial brought to you by MATLAB Helper. In this video tutorial we'll see how to compute discrete Fourier transform and fast Fourier transform along with inverse of these transforms when a sequence is given. Discrete Fourier transform is mathematically defined by x of k is equals to summation n is equal to 0 to n minus 1 x of n, which is our sequence, into exponential of minus j 2 pi kn by small n. Here k is equals to 0, 1, 2, 3 till n minus 1. Similarly, inverse discrete Fourier transform is defined as kn is equals to 1 by n, summation k is equal to 0 to n minus 1 x of k exponential of j2 pi kn by capital N. Here n is equal to 0, 1, 2 till n minus 1. This formula is similar to above formula, only the difference is in the negative term of exponential and the sequence is multiplied by 1 by n. So this is the code for DFT and we are taking a sequence containing 8 samples, and so we define n as 8. We also need to define the imaginary term j as square root of minus 1, and then we write a sequence x of n as 1, 2, 3, 4, 5, 6, 7 and 8. We also write a empty sequence x of k with all 0 samples, which is our output sequence. Now the formula for DFT is here, and we implement the summation using for loops in MATLAB. So to plot magnitude, we need to find absolute value of x of k, and to get phase plot, we need to find the angle of x of k. Then we stem plot them in a figure using these commands. We plot wk, magnitude and wk, phase, and the output DFT is this magnitude and phase plot. Now to find inverse DFT of this output DFT, we implement the mathematical formula of inverse DFT using the same for loop techniques. The formula for IDFT is this, and the only change is negative sign in exponential part, and the sequence is multiplied by 1 by n. Now we stem plot t, xn, where we have already defined t, and we get the inverse DFT output as the same input sequence. In DFT, the number of computation goes very high with increase in number of samples, and so a new algorithm was developed called fast Fourier transform algorithm. Radix 2 fast Fourier algorithm is most important algorithm, and on further division there are two types, decimation in time and decimation in frequency. But in MATLAB we have a direct command for computing FFT. This is a code for FFT. We have chosen a 4 sample sequence 1, 1, 2, 3. To find FFT, we directly input the command x of k is equals to FFT xn, capital N. Now as we did in DFT, we separate the magnitude and phase of the obtained FFT. We also find the inverse FFT by the command xn is equals to IFFT x of k, and then we plot them into the same figure. We stem plot n, xn, our input sequence, and n, capital Xn as our inverse FFT. Then we plot wk, magnitude and wk, phase, where we have already defined wk as 0 to n minus 1, and we get the output. Here we see the input sequence, FFT of the sequence, that is magnitude and phase plots. Also we see the inverse FFT, and we notice the inverse FFT is same as that of input spectrum. So this is how we compute discrete and fast Fourier transforms along with the inverse of these transforms. Hope you guys liked the video. Don't forget to hit the like button. Also subscribe to the channel for more videos on such topics. Thank you.